another episode with the Focus on Geothermal webinar series. This is a joint effort of Think Energy and our partner, Enerchange. Once again, I am Carlo Cariaga from Think Energy, and today we have the pleasure of hosting Naeem Sadiq from Oxford Well Engineering. Today's webinar will be on the use of smart digital approaches and modern data technologies for designing and drilling deep geothermal wells. We will go into how well costs can be reduced using smart digital drilling and how more efficient and longer lasting wells can be built with data-driven well design. Our speaker today, Naeem, has over 23 years of diverse drilling and wells experience in the USA and the UK. He works hands-on with both offshore and onshore projects. He is a UK chartered engineer with a master's in science in petroleum engineering, and he currently operates his London-based consultancy, Oxford Well Engineering Limited. The company has been successfully running for over 7 years now and has a diverse portfolio of global clients in the drilling and geothermal sectors. He is also a visiting lecturer at the University of Leoben in Austria for MS level drilling topics. For the audience, before we start, please type in your questions at any point. We have a questions tab there at the webinar panel. We will get to those questions after the presentation. And Naeem, the floor is yours. Welcome.
Thank you very much, Carlo. You mentioned 33 years experience. That's actually 23. So I'm just joking, but 33 is as good as 23. Only part is that I will be sounding very older person, you know. So, but anyway, so yeah, I would like to introduce this topic. This is something that I have been involved with for a very long time. This is the digital technologies. People contact me for optimizations. When they come to optimization, they wanted to just aim for reduction of the well cost. It could be the geothermal well, oil and gas wells. The focus is to how to reduce the well cost, and more importantly, without compromising on the well integrity and productivity of the wells, and kind of not to cut the corner, basically. So it is hugely important not to confuse it with cost reduction. If someone comes to me and say, I want to reduce the well cost, I would say to them, okay, show me your data, give it to me, tell me everything about the challenges, because we need to right fit the solution based on the challenges. Okay, so let me start this short webinar. This will give you a kind of glimpse or the window into the world of these digital technologies that you can cherry pick and make it yours by finding the right one for your particular challenges. So I'm going to focus on the slides. So I will turn off the camera so we focus on what is being presented. Okay, so 2 seconds, let me just hide things here. So deep geothermal wells are notorious for the costs. The costs can run away. Before you know, you are drilling very expensive wells. And sometimes the money runs out so much that you stop drilling. They say, okay, it was a bad idea, or sorry, we could not do it. Because the investors are not very big, let's say, supporters, or let's say they don't have deep pockets. At one point, the money spent is so much that you could not drill them anymore cost effectively. You say, okay, that's it for me, and let's do something else with it, or what, you know. So these are very powerful kind of technologies, but you need to be very careful. That's why I wanted to have this short webinar with Think Energy to share our expertise. I have 23 years of experience, mainly working with drilling optimization side of the things, worked in a lot of places, all kind of different models, different technologies I have used personally, and in the face of different challenges. So this could be a good kind of a small chat about what we can do for deep geothermal wells. Okay, so let's get started. The webinar agenda is looking at as a kind of, you know, observer to see the drilling performance, how drilling performance differs when you have geothermal wells comparing with oil and gas wells. Oil and gas wells, people have been drilling for more than 100 years. And geothermal wells are also kind of building this experience, but they do not have that kind of bandwidth and so much experience. A lot of geothermal wells are drilled as a construction project, like a small project with construction of these things. And the crews are not coming from maybe so much experience with optimization and the designs and the things like that. So we will show you the glimpse how it looks as we speak now, as we are dealing with these challenges. So drilling performance, we talk about that, and we talk about how you can actually go about what is the roadmap, loose fit roadmap, because there is no specific roadmap you can have that fits all the sizes and shapes and challenges of the geothermal wells. So we need to have a high level roadmap so you can get the kind of starting point for your particular set of wells. Performance gap analysis is digital empowerment. Performance gap analysis does not have to be as boring as just doing the analysis. You can actually do the performance gap analysis in real time. When you are actually drilling the wells, you can divert and correct the course of actions. So you don't find out the lost time and the failures later. You can actually find out now as we drill every day. You can actually control for the geothermal operation on the leash. And then lastly, we talk about a little touch of automation, AI, and machine learning for deep geothermal wells. Automation, AI, and machine learning are getting cheaper. So is the data technologies. In the past, you need to find someone who understands them, who can use it for your. Now it's flourishing thanks to the oil and gas industry, because they are big investors in automation. For last 5 years, I still have to find an operator who does not want automation and AI and machine. They all want it. They want it now, and they want all of it. So why not think about these to use them? Because they are not so expensive anymore. They can cut down the learning curve and reduce the well cost, and we can also benefit from it for our cheap geothermal wells. Lastly, we'll talk about some questions and comments. Okay, so we talked about the performance gaps. What is the difference, how it looks like? There is a small study done in Colorado from Colorado School of Mines, and it was published actually. You can see for the new guys who do not drill all the time and they are not drillers, just to explain it a bit, this chart shows two groups of wells. One group is oil and gas wells, and which is showing by the circle, and the rectangle, which is the group of geothermal well in the same area, which was in Colorado, by the way. And in this, you can see oil and gas drill fast, taking 20, 30 days, and maximum 35 days or whatever, something like that. And on the geothermal well in the same area, they had been, from the comparisons point of view, it looks like a disaster. Why would you say it's a disaster? Because look at the shape. A lot of step profiles, a lot of humps. If I may show you with the pointer, look at this hump there. Okay. Okay, let me just try to highlight. Sorry, this one. Okay, so look at this one there. This is the hump. This hump means they sidetrack. They got stuck or something. Look at the character of these slopes. Step, 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 and look at the character of the oil and gas wells. Not too many steps. Step means horizontal, vertical, horizontal slope, horizontal slope. Horizontal means lost time, flat time. People call them flat time in the drilling business. Flat time is a bad news, but flat time is necessary as well. If you are running casing, you're not drilling. It's a good flat time. But if you're struggling, And then you could not drill, you could not run, you could not make progress towards the construction of your well. The step profile comes up like this. All of these geothermal well, looking at the character of it, it looks huge amount of flat time hidden between the slopes. Look at the slopes. But good news here, when they get going, the slope is not terribly out. Slope is similar. Similar slope means the rate of drilling, rate of penetration, ROP, for example, is okay. It's not so bad. It's just they could not drill continuously. They have run into problems. They stop it. That's why the flat time comes in. Without being too technical, because I deal with this all the time, so I may be a little bit more technical. And the flat time is bad flat time if it was not in the plan and you got to see it by running into problems and sorting things out. Time is being spent and we could not drill down. This is the bad flat time. And bad flat time could be a failure. It could also be invisible, that you don't get to know what happened, why they stopped drilling, why they are circulating, for example, not able to do this, not able to do that. These are bad flat time. And a lot of this does not get reported. Digital technologies can automatically detect and put it on the table, all these small bits and pieces of flat time. When you combine the small flat time together, sometimes it comes as high as 10% of the drilling time or the rig time that the rig had been doing this project. The whole well time, 10% of it is unknown invisible time. You can catch it in the real time. As I mentioned to you, you don't have to do the post well analysis to catch it. When you're drilling it, you can see where the invisible lost times are being spent, and you can actually intervene. That is the best part of using digital technologies. You don't get to tell the story after the effect. You actually can intervene on a day-to-day basis using technologies and the visualization, and they are not expensive, by the way. If I'm spending $100 a day for an expensive rig of $50,000 a day rig, I am getting a lot more basically out of my analysis. So those digital technologies you can tap into. You can say this particular area, there had been certain geological challenges. That's why this does not represent what I see elsewhere. Let me show you another one, actually. So let's take you to the next one. This is the one from Africa. Same story. All of them are from different fields. They are actively drilling 12 wells, 15 wells in a year. The first in any field, the encircled ones are the ones that they drilled first. They ran into all kind of problems. Then they start to learn from it, and you can see the shifting to the left. They were drilling the very first well are the ones that are in the rectangle. I've got some friends working in the area. They talk to me all the time about these wells. This is what they don't like. When they go into a geothermal field, the first 2-3 wells are too expensive. Look at here. It's 80 days compared to 50 days or 60 days, 50% improvement as you drill. Because they use this experience of conventional drilling. Conventional drilling loves the learning curve step profile. And look at in the middle, the same story. The first few wells were very expensive. Then they get better and better by learning, by doing it, by running into obstacles, fixing them, what not to do. They learn by doing it. And look on the right-hand side, massive sidetracks, a lot of sidetracks, maybe two in one, two sidetracks, one sidetracks. All these humps are sidetracks. It's not optional. They run into problem. They could not come out of it. They bury the BHA and drilled again. So these are the things that is all around the world. Usually, as you know yourself, geothermal wells are drilled in doublets, most of them. They have injector, producer, combination. They don't get to go to the fun part, the optimized version of their wells. They drill first to well, most expensive, because this is how the drilling team learns if they are not going digital. So these are a little trouble with geothermal well. They are drilled in doublet. They are not a campaign of 10, 15 wells a lot of times. Sometimes they are. For example, in Kenya and other places, they drill 10, 15 wells in a year. They are okay. After 2 wells of suffering, high expensive costs, they can get to the comfortable zone of drilling, where the cost is okay or not so bad anymore. But for in some operators in Europe and other places, we just got to drill 2 wells and we end up with very expensive wells because we are using conventional approaches. Okay, so this is the kind of view into the problems and how we have seen it around the world. Now, have a look at this one. This is the typical drilling curve. Suppose I am a geothermal operator in Africa. I drill 10 wells. My first 2 wells, okay, so just trying to click it. Yeah, so my first well will be the green well, the first green well. My second well will be 74 days. This step profile is very common. Any drilling campaign, you plot the duration of your well. If the wells are similar shape and similar style and everything similar, then you will have a step profile like this. You did all the mistakes and then you learn, you fix this, you know what to do at what depth, in what section. The crew is getting trained by doing things. So this is the normal drilling learning curve. However, if you are able to digitalize, apply the digital empowerment for your well on the both side of the coin, well planning, well design, and also when you're drilling, you got to start with the purple one. Okay, this purple one is your target. This is what it should be like. You usually drill 2 wells in Western world. You are only drilling 2 wells, injector and producer, a lot of places. So you end up with 80 and 74, not 65 and 60. There's a 10-15% difference right off the bat. If you use digital technologies properly, especially in the design phase, you need to have the blueprint improved with the digital technologies. There are ways that people have been doing it. If you come to any big operator right now and check out their real-time center, how they're doing, what they're doing, when they're planning, everybody comes to the real-time people's desk, collect these bits and these pieces of information, improve the designs. They know what was easy, what was hard, and what needs to be injected into my designs and the well plans and the operational sequences, and then come out with a very super fine, basically, drilling program and instructions for constructing the well and drilling the wells. So this red step profile is normal, and this purple one with the black steps on it should be our target if you want to be cost conscious and deliver the well at a decent cost to start with. Okay, so a very high level. This is a bit complicated, but I'll try explaining it. If you want to say that I want to drill this geothermal well, the first thing to do is to go for a deep digital offset analysis. What it is, in simple words, is to not to read all the DDRs, not to just review all the logs and how people had been doing what they had been doing. This is just a one part of learning. The real digital offset analysis is to actually reconstruct your offset well. If you have enough data, you can reconstruct your wells retrospectively using this real-time expertise. Only thing is you're running the data historically. You are actually pulling into the visualization packages and the analysis. You are pulling your offset well as if you are drilling them. And then you already have all the information about failures and all the things that had happened. So you can actually make sense of your analysis using these digital visualization packages. They are very much available. Some of them are free actually. And invisible lost time, check, covered. Failures, figure them out, and then you can see them happening. If you have done a good job with offset analysis, every failure, any failure, you get to see it happening. You will see them happening because you recreated the well, the event that are leading to the failures, stuck pipe, for example, having problem getting this and getting that. You will be able to see the true root causes supported by the data. No one's opinion. Everybody have opinion. If you have experienced people, you may have 90%, 80% success with correct opinions, correct solution, correct root causes said by these gentlemen and the ladies who are experienced. But data is the one that actually gives you everything. You like it or not, it tells you. If you are using the data correctly, visualization correctly, it's very empowering. It will tell you what is causing it, what actually have caused it. Maybe you will be surprised with the truth it can show you. And in normal situation, you get some kind of calibration with what experienced people are saying, but sometimes it does not. This is where it shines. Either it supports it or it tells you the other way around, and the experienced people learn that they may be wrong. For younger people, I would say having this digital expertise on their side, it's a big thing, because if they lack experience, but they know these things to be done right, they can explain, they have done their homework and due diligence, they can be as powerful as people with 20-year experience and work with them more harmoniously and improve the performance of the team basically by bringing in these technologies supporting the project basically. So I just wanted to say that you feed it into the planning. All these learnings from offset well, it takes time, of course. If you have 3 wells, if you give these wells to people like myself, I will work with them in 2, 3 weeks time. Especially, I will be focused on the failures and the gaps when they could not get what they wanted. I can recreate and focus on those events and recreate them and learn from it so I don't get to see them again for my future wells. Then you feed into the planning, into the design selection, and you perform the analysis and everything in the light of it. You will exclude things, you will include things. If you see something did not work, some design things needs to improve, then you will change the design accordingly. So this feeding the funnel of these designs and the concept analysis, everything needs to be done right. If you are missing the first step, what you're gonna get is the old-fashioned drilling step profile. You already construct the blueprint. It does not have any shortcuts, any optimization. You will just go construct it. At the end of the day, it will be still waste of money and time. So number one is critical. That's why I ticked it with red color. Red means you must do it right. And then you come through these all these analyses and get things ready to drill. Number 3 is getting ready to drill. You can still use these calibrations. You can call it red. Red tick again for the real time. With the real time, you're riding on a bull or something. It's fast and it's going. It's very risky. And if you don't get it right, your cost will run away. Everything can go, out of sync. And before you know it, you have very, very expensive wells. That's why I dotted it and ticked it with red color. You need to play this drilling optimization right. When they are drilling the wells, you need to use digital technologies. When I say digital technologies, I mean to say optimize it when they are drilling so you can change things on the go. You don't have to tell anyone a story after the well because that's like complete loss of the idea. So have a look at this one. For example, this is just for the kind of showing you this plot. This plot is telling you an offset well. Suppose you are interested to see what happened to one of my offset well. Can I learn from it for your geothermal well, for example? You can plot them only bit depth and the time, hole depth and the bit depth. So you plot them only only three things. You color code them. You can say the blue is running in the hole, green, you're drilling. So you get to see the drilling ROP. And then blue is pull out of the hole or making a trip. Making a trip is blue. And then silver color running the casing. You can color code it very nicely. You can do a lot of things with simple plotting. You don't need even softwares for these things. I've done this in Excel because I did not have these expensive softwares. But you can have a slightly expensive software, maybe a kind of cheap one that can give you these. Very easy to construct it. Only three parameters. If someone asks you, what was the ROP from 700 to 1800, you have this green slope. You can calculate the ROP out of it just by looking at it, actually. You can calculate. And how about ROP had been consistent? You can say yes or no. Had it been slowing towards the end of this drilling? Yes or no? Because you can see the laziness of this slope. You can quickly pick which formation had these slow ROP, which formation had faster ROP, what you can learn from it, and also the flat time. If they are not drilling, flat time comes in. There's a flat time here at 650 meter. What they were doing, the slope is slightly less. Actually, you can say they were drilling cement. After cementing the casing, they want to drill out of it. So that's why. And what kind of speed of drilling? You can check it, and then everything was fine. So this is the successful well. Basically, you can see there's no flat time while drilling. If you had a problem, these nice green line slopes will be step profile, which means they could not drill at certain depths. They waited, they fixed, or whatever. On my right hand side, you have finishing of the well. They made the short trip. You can tell the story just by looking at it. And when they pull out of the hole, look at the bit, information about the bit, how badly the bit was actually damaged. It's got a high numbers, 3 and 3, cutters are broken and things like that. So now you say, okay, I have done a good job with ROPs for the last section, the green slope, but my bit had been all broken. Maybe I need to improve the bit. If I had a better bit, maybe I could have better ROP, which I did not, which was okay, but it could be even better. So you actually, just by looking at the things, you can empower yourself. What could be done and what is the focus point, which area do I need to focus on, just by looking at it in the plot like this. Starting point, by the way. Then you can zoom yourself in. If you don't have to do this short trip, for example, look at this one. The green, you drill, you get to the bottom, and then you make a short trip. Why did you make a short trip for? Because you wanted to make sure you can run casing later, or the driller liked to do it. Did they have any problem in the past running casing? If answer is no, then maybe consider checking this to see if you don't have to do this short trip. If you remove this short trip using the digital analysis, for example, if you ask me, do we need this? Yes or no? Do we need this to go up and down? I will say, okay, give me the offset wells. If you give me offset wells, I will plot them. They may have done the similar exercise there as well. I will check them how easy it was to pull out. For example, here, they pulled out nicely. No stopping all the way up there and come back down, no stopping. If there was a stopping, you will see the step profile. horizontal in the middle somewhere. If all of the offsets have no problem, I will say, let's try removing these half a day or 20 hours of tripping. Go straight from here all the way to surface. Let's try that, because now I have this data technology telling me maybe it's redundant. We don't have to do this step. So those kind of things add up. One day on the rig, $75,000 or $50,000, depends, where you are. Why not use digital offset analysis as a big picture, as a small picture, but it will really help you getting the grip of what are you dealing with, what kind of well you will be dealing with. Okay. And now let me take you through, because I think this is the time. Similarly, if you have drilled certain well, you say, okay, I drilled this well, geothermal well, I ran into all kind of problems, and this is the kind of distribution of my failures. When you drill a well, you have non-productive time, aka failure time, where you have lost time because of non-documented failures. Non-documented failures or losses and issues that had been documented, and people say, this is my non-productive time, where things happen, very bad things happen, and I spend this much time. Now, on my left-hand side, it is showing the number of hours I spent. On my right-hand side at the bottom, it is telling me what event that was. Waiting on equipment, 150 hours of waiting. In remote areas, it is possible. Casing did not arrive because there was some issues or whatever the issues were. People are waiting for casing to arrive so that they can drill. They can drill and case the well. Sometime it happened. It did happen, actually, with some of mine. Similarly, a BHA cannot pass through the conductor. Somebody installed the conductor and conductor got bent. When it got bent, it collapsed. So whatever you run under it, you cannot come out of it. So 130 hours, because they did the reaming and milling and everything. Several of these runs, they spent 134 hours. So you can put all your failures. Total number of hours of failures is 657. Total NPT hours. Then you can color code them to see which one you can fix or you think you can fix. For example, I cannot fix waiting on equipment because there was some problem in logistics. We cannot fix that. Technical guys say, okay, I can try fixing this problem. Maybe conductor get bent. I want to investigate why it got bent. When you hammered the conductor, how that was like, what caused it. I will investigate it so I don't get to deal with this again. Similarly, you run the completion, cannot run the completion because of the drag. I want to investigate that drag using digital technologies, using data analysis of the actual data. When you're running the completion, you have actual data. You have actual roadmaps from digital technology. You can plot the digital roadmap, and then you can track it and see what was the mistake. Because completion, you don't want to run them if you see that they are going to be stopped because the drag is overwhelmingly high. Only digital roadmap can tell you these. People do it a lot, but not like this one. We need to actually calibrate them. We need to make your drag roadmap live. With digital technologies, you can calibrate them. When you are doing it, you have to have it calibrated. So you would know if it will go or it will not go by doing the analysis, even before running the completions. So you can do all these tricks. You can say, okay, these amber ones, I will investigate and try to find the true root cause. Then you go back to your offset well and recreate these events using digital technologies, real-time expertise. You can actually visualize each one of them to see what was the true root cause for a stuck pipe, for hole conditioning, the wiper trips, difficulty of these, issues with that. Excuse me. So all these things are really important to understand. Yeah, and then you can actually use it to your advantage. You can even put the money on it. You can say, if I can fix the second point, I may be able to save 134 hours of lost time that I previously had. Excuse me. So let's come back to this one. So this is the kind of roadmap, digitally optimize at every step of the way. This is something that I used, all by myself with a lot of different wells. And this is the loose fit. You can customize it. So first thing is about to have the conceptual design. For the conceptual design, you want to use a lot of data. You want to drill from the right location. If you're drilling from the wrong location, and the wells could be a very kind of shape that could be more expensive. If you change the surface location, if you know you have more surface location than you think it is, consider running the analysis. What surface location will make my well better shape, easy to drill, shortest possible? I don't have to kick off here. I don't have to kick off there. The dog legs, the kinks and bends of the well depends upon where you are drilling from. If your targets are fixed, in our geothermal case, sometimes you have very fixed targets, but your surface location may have some options. If you change the surface location, you change the goalpost, you change the shape of your well, and also the preparation of the site selection. If you select the wrong rig, there is a digital technologies domain thing people do. If you want to select a rig, perform rig KPI analysis. You may have 4 rigs that you can choose from. If you do a mistake with them, you will pay millions over the course of your project. You will pay 10% of extra cost because you picked the wrong rig. The rig is drilling, no problem with that. It's just invisible lost time the rig has. Okay, I will explain it to you in a separate slide. So because this is important topic, then you go with digital side of a thing. You infuse it with the rig selection, the site selection, and then you go for the well design and the well planning. You want to optimize them alongside. For the well design, what could be the digital input for it? You will check on previous wells, how they had been designed. Are there, and also see how they actually had operational problems. For example, if you had problem in the curve part of the well, when they had the curve, in the curve they had all kind of issues, hull cleaning issues, difficulty running strings, or maybe the collapsed well boards. How about reducing the tortuosity in the curve section? Maybe the data will tell you, the digital technology will tell you that this zone, this area, or this operation had been problematic. They will not tell you how to fix it. From there, using the digital technology, you will see what is the root cause. Is it the curve, the dog leg, or the whole inclination through certain formations that it is showing problems? Because you can visualize things and you can find out this appears to be related to this problem or this, the existing conditions. So anyway, we can spend all day on this one slide, but I don't want to do that because this is the short presentation. So detailed well design, this takes you to the nitty gritty of the things. You will bring in the calibration from the real time stuff. You can verify, you can pin down the limits. You can tell how the drilling would be like, what ROP is good for me. If something happened, what do I do to fix it? Okay. Let's come back to the writing the instructions of drilling program. Instructions for the driller. Okay. Instruction should be coming from also including the digital information like We have done this in the past and it did not go right. Instruct the driller, do it in other ways. For example, KPIs, drilling KPIs. What KPIs and what you learned from KPIs in the past, you inject it into this instruction. That guys, when you do the connection, do this and don't do that. Stuff like that, you know. And then on the dotted line, we are looking at other side of the coin. On the left side, you have design, planning, analysis, digital, programming, everything. On the right hand side, you are doing it, you are constructing it, and digital very heavy on the right hand side because you will be digital all the way. On the left hand side, you will actually doing it in a customized fashion. But here on the well construction side, if you want to be on the top of your cost, you have to have digital technologies supporting you, because no one with human power can do it efficiently the way that you can get support from digital technologies. Okay. Needless to say, okay, let's come back to the well and another busy slide. I have to show you this one because this is the most important actually slide. If you are trying to reduce the cost, you have to understand, most of us understand. For example, if you have a well that finished in 10 days, you constructed in 10 days, let's say 20% of its time is the failure. It deals with failure. Rest of the time is classified by the rig people, and the reporting will say, okay, 80% of the time was productive time because I followed what I have programmed, what I had in the program, I followed it. I spent time following the program 80% of my total time. 20% was my failure. But in reality, this productive time carries invisible lost time. This productive time has a hidden inefficiencies. We call it invisible because nobody reports it if you go conventional. If I run data technology on it, find out which KPIs are lagging, which operations were redundant, they should not have been done, then I got out of it productive time. A part of it will come out to be ILT, invisible lost time. It could be 10%, it could be 20% of the rig time. If you are really in a bad shape, it could be 30%. On the deep water rigs, in the very expensive wells, it's 2 or 3% only. But for geothermal, you'll be surprised. It's most of the time 10% or more. So now you got these things. You go from left to right. If you are efficient, if you are an efficient drilling team, you understand, okay, my productive time is not really productive. Maybe some part of it will be invisible lost time. You identified it using data technologies. Similarly, for NPT part upstairs, you say, I want to reduce certain things. I want to improve certain failures. So next time when you drill the well, you will have less NPT and you will also fight off with some ILT. Once you identify it, you cannot reduce ILT unless you identify it. Why? Because ILT will tell you connections had been the problem, running speed had been the problem, the rig is or the night crew is not performing at good efficiencies compared to the day crew. Things like that. There's a whole list of the KPIs you can use. And then now you know what to fix. So you cannot do anything unless you identify it. So if you are smart with this, you can keep reducing the well cost. Ideally, you don't have to do it in steps. If you do all the homework, as I mentioned to you before, you start somewhere in the middle and then go optimizing from there. Okay. So I will not take too much time here because the time is slightly tight. So you can ask question you wanted to ask. But this slide is telling you on the left-hand side where we usually are. And the second column telling you where you should be starting your journey towards. And the most right-hand one is where you should actually be starting from. If you have people with experience, with digital technologies, with drilling experience, then you should start from the right, not from left, but we start from the left because that's easy. People go in autopilot and then say, okay, now I think it's too expensive. Well, I don't see any reason why this is too expensive. Let's run ILT analysis. It's too late. You already paid for it. So many expensive wells. You don't want to do that. You want to start from somewhere in the middle or from the right hand side somewhere. So you have everything figured out, ready. Then you plan with this empowerment using your offset well, of course. Then you go faster towards the cost saving. Here is an example, just for the people who like examples. Show me, tell me. Suppose that you want to drill geothermal wells. You have 4 rigs you wanted to pick with. You want to say, okay, rig 1, 2, 3, 4, out of which suppose 3 and 4 are available to you in the area. Rig 1 and 2 are not available. Let's just assume that they are in some other country. It will cost them so much money to bring it. 3 and 4 are you wanted to look at. And 1.39 minutes and 2.27 minutes, showing them how much time it takes them to make a connection, how much time it takes them to make one connection when they are drilling and tripping or what, So this is the chart for the rig. You call the rig and say, give me your connection time, rig number 3 and rig number 4, so I can do my analysis. Just by doing this analysis, you can actually come out and go to your drilling program. Say, okay, my drilling program, I want to do these steps, run in the hole, drill this, run casings and everything. And for the sake of simplicity, I put in a table to summarize what I wanted to do. How many stands will I be doing in first step? How many stands will I be running in with this step? And for the simplicity, I make them simple to show you the total of this. I'm trying to calculate the total number of connection my well will require. I did the calculation out of the instructions, out of the plain instructions from 1 to 17. I come up with this table. Then I plotted my table. I have time and depth now. And the blue curve is telling me what will be my total number of connections for my well. If I pick rig number 3 compared to rig number 4, the difference of the number of days is 11 days of the connection times. So it is such an important thing to remember. The rig needs to be with the good drilling KPIs because you will be paying so much money of invisible lost time. It never gets reported. So do your homework before you pick up the rig. Do the KPI analysis. It's everywhere. It's very low cost, by the way. You can do it within 2 days, maybe within 1 day. There's an automated system that does it. It can ingest the well that rig number 3 and 4 had drilled. It runs the analysis, give you how it had been doing 50 percentile of the connection, not just the connection, every KPI, a lot of KPI. What I gave you here is just one KPI, connection. It saves you $1 million. How about 25 other KPIs? Okay, there are other KPI, running speeds and things like that, tripping speeds, casing stuff, making up casing connections and things like that. This is just for one KPI, one rig. If you do a mistake, you will pay around $1 million for one rig, but there could be other KPIs. They could be counter effective, like maybe some of the rig KPIs are good in one and bad in others. So you have to do your homework. This is just to give you a flavor of this. Okay, performance gap analysis, invisible lost time, as I mentioned, it's invisible. Examples of these invisible lost time, ROP is too slow than expected. It's one of the lost time. And people say it's not broken. It's not, nothing is wrong. True, but you could do better depending upon what the task is. Okay, so what do you need to monitor as a KPI? Which KPI do you need to focus on? You can go 6 KPIs, 8 KPIs. But usually you want to focus on the KPIs that are routinely used, making connection, running in the hole, ROPs, things like that. Okay. So you will be focusing on the KPI that takes too much of the rig time. All the KPIs, most of the KPIs, 30% of the rig time, 40% of the rig time that you can actually tap into and optimize. Here is another example. I talked to you about location optimization. Somebody came say, okay, this location is good for me. I told my vendors, the directional drilling provider, they gave me location A to drill from. I want it to be at 55° and 45° azimuth when I am entering and hitting my target. Then somebody said, okay, and then I asked them, what is requirement? What is the requirement? And they told me, we have other locations available. We can go any locations close to the target, but we must have 55° inclination and 45° azimuth. These two are my hard line, that any location should be able to hit. So we optimize it for them. Location A, I said, let's try location B. How much money we can save? And then we say it becomes shorter. The well becomes shorter. Then we say, can we go the best possible case? As long as we follow what you ask us to have, 55° inclination when you are hitting the targets and 45 azimuth. They say, yes, that's fine with us because we have a lot of spaces. We can drill from anywhere. Then location C comes into the picture. And there you go. 1.3 million savings using the cost of drilling they had in their books. 1.3 millions by actually optimizing the surface location. The circle you're looking at is telling you you can drill from anywhere if direction of drilling is not a problem. Suppose the gentleman comes in and say, any azimuthal direction will be okay for me, then I can drill from anything from around this circle, because I draw the circle around it having this much offset. So you can drill from here and drill like this, coming from other direction. So there's a lot of money needs to be saved with these smart interventions. If you are a small geothermal operator, I would suggest to go with this option, not to have a real-time center. You can have a desk. You can just have a desk for real-time center. You can train someone to run this desk. You can do everything that the real-time center does. It will not be 24/7. It will be only customized to suit difficult hole section. For example, if you have certain hole section or certain operation that you wanted to do the real-time operation and analysis and solution and problem solving in real time, you may engage it, you may disengage it. You don't need a 24/7 for the whole duration. It will be too costly for you. So this is something that people are doing it actually. Small operators do that. And for complex wells, for tough, geothermal wells, I would go for that one. You can use it, okay? I will skip out a little bit and take you to, this is the full time. If you have a complex well, you want it to do very difficult wells, this is how it works, The data comes in and we perform the analysis with digital technologies, KPI, invisible lost time, a whole lot of things. I cannot even explain it maybe in 10 minutes, to explain what it does there. But it will be comprehensive. People can spend a lot of money on it, or people can do less of the money by having a desk, just a desk. Their own guys and the girls can get trained and they can get almost the same benefits, almost the same. Why almost? Because 24/7 is 24/7. If you get engaged with it and then you leave it, you are not continuously connected with it. Okay. So this is the setup for a big one. You have two guys if you want to go full on with very complex wells, but don't have to worry about that one. That is maybe not for small operators. These are the case studies people had been doing certain operations. I'm not going to spend too much time. It is telling you that real-time center, people intervene. Rig was doing something that they should not be doing. It was not necessary. It cost them quite a bit money, a couple of days of the operations time. They say, don't do it. It's not necessary because we saw it through the data and analysis. This picture is telling you tripping. You trip in the hole. That is your amber color. And you trip out of the hole. This is your blue color. In both cases, the tight hole conditions highlighted by the rectangles are still the same. No improvement, zero improvement for running this special trip to improve the well. So we suggested don't do it because it's not helping. And they saved one day, $75,000. Okay, so doublets, this is another example. People have drilled doublets. For each well, it took them 15 months, whole lot of sidetracks because of not using these digital things that we talked about. I'm not going to spend too much time. Automation, this is a kind of good topic, very interesting. Automation and AI and machine learning. I had only one slide here for you. I could write 10 of them. I believe the important point is to use the digital technologies first, which are more powerful and they are calibrated and people have used them successfully to tap into the big savings. AI and machine learning and things still growing, even with big operators, big oil and gas people with deep pockets. They have only very small success for big cost events, big solutions. Stuck pipe, for example, it's 50% success, 40% success for achieving this and that. So for this one, I think that could be also used for automation of alarms, using the complex logic. The character of the well, you can classify the well using this automation. If you are drilling the well, you can say which parameters. I can actually use the machine learning algorithm to find out previous well that had drilled with the same section, same formation, what was their best ROP, and what was the operating parameters I can use, meter by meter. Actually, I have used this system more recently. I love them, but it is still not giving you the answers in the way that digital technologies that I mentioned can give you. Of course, they will come through. They will be stronger. So you can use it for well control. You can use a variety of the things, this automation, AI, and machine learning. Also for the drilling KPIs, you can use a lot of automation with it. Okay, the second last one. Some people are actually experimenting with fully autonomous drilling. They will have automatic system. The driller does not have to touch any lever or any dial. Some system is doing it for them. It's a bit dangerous, but people want to experiment it. I'm not going to mention the name, of course, but this is coming through. It's not for geothermal at the moment. You can use some of it, only the small bits and pieces. Okay. So where to start? The last slide. Consider reaching out to people with right expertise and passion. You cannot get anything done if you are swimming in the same soup, dealing with the same people, same technologies. You are actually isolating yourself from the connections and the solutions. Better to reach out with people with diversified expertise and, of course, the passion. Create a roadmap. Create a roadmap for design and well planning. And in that roadmap, you have digital technologies according to your challenges. There is no fixed roadmap. You create it with the right people, then you get a roadmap that delivers. Create a digital drilling optimization roadmap for efficient drilling execution. You create a program of drilling with these optimization inbuilt into it. Then you go drilling it. Then you do the real-time drilling. So this is like a small, let's say, approach you can follow. And I will And then what you do in the drilling phase, you feed back the loop. This is the most important part, because you may not be 100% successful in everything. Then you got to feed back the loop to make it perfect next time. Okay, I will stop it here and maybe see if you have any questions.
Hey, thank you, Naeem, for that fantastic presentation, and it's a good preview for say what the geothermal drilling sector industry can look like in the next couple of years, decades. So let's go through. We don't have a lot of time, but let's go through some questions, some interesting ones. Is there any specific training or expertise or tools that say an operator or a driller would have to learn or to develop to implement such digital well design or drilling methods?
I think the first step is to get to know the technology, and not to just jump into this because I like it. I like the visualization. I like this. It makes sense. Learn the basics and then build from there. Then you know what is good for you, because technologies are everywhere. Some technologies, they are sort of snake oil. You will like them, you like the feel of it, but it does not save you any money. People who are experienced know already about it, and that's why it is taking very long to digitalize in various companies. So come talk to us and tell us your challenges, or people like myself, and we can talk about what is the starting point for your particular requirement.
Okay, then you talk a lot about invisible lost time, and by its nature, this is something that I suppose is quite hard to identify. Um, is there, based on your experience, what are the common occurrences of invisible lost time, like especially for geothermal wells?
For geothermal well, it comes from the way that the rig does things, the rig operations, how it makes connection, how the day crew works, how the night crew works. Sometimes there's a big difference between the night crews and the day crews. One crew is doing it in certain ways. The most important word I want to say about invisible lost time is the consistency of the operation. How consistent the connection time is, for example, 3 minutes, or sometime it is going from 3 minutes to 20 minutes. So these are the things that come. If nobody sees them, they will be not like a bell-shaped curve. They are spread out and very inconsistent. But this is just one KPI. There are a lot of things that only automated invisible lost time analysis. There are technologies everywhere right now. Use the right one and comb through the drilling operations and find out which KPI had been consistently lagging or not kind of efficient. Then you have a feel for how much time we are talking about, and then you talk to the people who actually can interfere and improve into the rig affairs. For example, tool pusher or the drilling supervisor. Tell them this is what you see. Show them the presentation of this data, and then things will get tidied up. I work for a company where we saw the rig has improved in visible lost time over this 12 months, reducing the number of days. So it is documented issue. It could be fixed by technology.
Okay, we have a couple more questions. Let's do two more at least. So, you mentioned something about real-time drilling optimization. It can be supported by say a remote team somewhere or a cloud-based data processing soft platform. How can this be done practically for say any drilling operations? Are there any specific or special field instrumentation that a drilling team would need to have to take advantage of such a platform?
Okay, yeah, as I mentioned, for a small geothermal operator, they don't want to have 24/7 real-time center. What they require is to set up a desk and train their people to run the desk whenever they are drilling, let's say, challenging section. They can enable that desk, and the guys and the girls can be trained for it. The data is coming in regardless of you like it or not. The data is coming in free using various. If you are drilling with any big company that is drilling for you, the data is coming for free. It's scrolling on your screens. So all you need is access to this real-time data, which is coming in for 90% of the wells. They are streaming the data anyway, if anybody use them or not. Uh, so the requirement of running this desk is very, very small. We just need to have right people who actually train the drilling team so that they can enable this desk. And believe me, there are people who are doing it. And I myself planning to travel actually tonight for the same reason, because some people want to do it in house. Okay, so it could be done. It should not take too much, let's say, money, because the data is now cheaper. Also, you just require the right training and somebody to mentor and be the part of this desk for some time until you guys are delivering the result. Saving money is not easy. Otherwise, we will not be having these conversations. So you need to actually tap into the expertise and deliver the success by seeing it. If the cost is reducing, you are winning. If the cost is not reducing, go back and learn more, or maybe engage more technology or more smarter ways of solving.
Okay, then. So we have several more questions, and we don't have the time for all of them. So for all of the others who are asking questions that we can't get through, we can't ask right now. If just feel free to maybe reach out to Naeem or even to us, Think Energy. You can also comment on our LinkedIn post, and we'll forward those questions and try to address them as well. But maybe just okay, two more questions then. There's a lot of interest on drilling automation. As you
Okay.
mentioned, like this is probably a very early effort, but what can you comment about the technology? Like, what are the gaps of it so far, and what is the further potential for it?
Gaps for the automation and these digital technologies are a lot of time it comes to the leadership. This is the leadership that actually enable and disable the benefits. If you have the leadership who are highly experienced, a lot of time we suffer from tunnel vision, and nobody wants to talk about it because people are bosses, people are very kind of in the powerful position. I can talk about it because I'm completely independent for that reason. So I had conversations with very strong-minded people, because the drilling people, they come very strong-minded. I'm also drilling, by the way. So uh, the first thing is to have the buy-in with the management. That way, you can pick the right technologies. Sometimes they pick up the wrong technologies. They go in the circle and don't save any money at the end. So picking up the right technology is mission critical. How would you know if it's right or wrong? Because you save money every section, the whole well actually, only even for the section, you save money. If you don't save money, what you have done is suboptimal.
Okay, so let's do just one last question then. From my impression of the presentation, it's I think that you're emphasizing that drilling costs can be reduced, perhaps without the use of fancy technologies. Like this is just focusing on processing the data, taking a closer look into the data that drillers already have anyway. So is this accurate? Like what can you comment about this seeming focus on emerging technologies versus trying to work with what we already have right now?
If you have something that you have been using, it cannot kind of outshine. It cannot outshine what you can do with the leverage of automated technologies. KPIs, I have seen them in the Excel sheet. I have not touched Excel sheet for a very long time afterwards when I saw the automated invisible lost time calculations. With the invisible lost time calculation, use it with drilling experts. Don't use it with data analysts. Data analysts, they have not been on the rigs. They don't know which KPIs or which numbers are correct. Because if you run any invisible lost time automated algorithm, you come out with 30% lost time, 30% saving of the rig time. A lot of it is incorrect. You need to get the right people to evaluate it, separate the wrong part, pick the right part that you can optimize. Going traditional, people have been traditional for a very long time. See what they have in their hands, expensive wells. So it's something you like to do it because it's easy, and people say, I want to use this more efficiently, then I can save money. Yes, maybe you can, but it will not be a step change.
Then you make an excellent point there that a lot of times data needs context behind it. So it's not enough to just look at the data and not have any actual knowledge of how drilling operations work.
Mhm.
Okay, then, and I think on that note, that's our webinar for today. Thank you, Naeem, for that presentation, and thank you to everyone who showed up. And in 2 weeks, we're going to have another Focus on Geothermal webinar, so watch out for that. Thank you, Naeem.
Thank you very much. Have a nice one, all.
Thanks, everyone. Have a happy weekend.
Cheers.
Goodbye.